Part B says, using correct units, interpret the statement, limit as t goes to infinity of a of t equals 12 in the context of this problem. So first of all, the units of a of t are in milligrams. So the limit is going to be 12 milligrams, and this represents the maximum amount of medication in this patient as time goes to infinity. Okay, so this represents the maximum amount. And if we take a look at the graph of that, if we recall the graph, there was a horizontal asymptote in this problem. So this also represents a horizontal asymptote. Okay, part C. Using separation of variables, find the y equals a of t, the particular solution to the differential equation that passes through the point 0, 0, or a of 0 equals 0. So first of all, we want to group the y's with the y. So I'm going to separate the y with dy. So dy over 12 minus y is going to be equal to 1/3 dt. Okay, so once I've separated the variables, that 3 could go on the other side. I'm just going to leave the 3 with the dt side. So I'm going to separate. I'm going to integrate both sides of this. So this becomes log 12 minus y. And because of that negative y, we need to use chain rule and put that extra negative on the outside. And that's equal to 1/3 t. And we have a plus c to solve for. Okay, so I'm going to maybe just get rid of this negative to start so that it's easier to work with. So 12 minus y. Remember that negative is on the outside log, so it can't go on the inside as a coefficient. It would be a negative power. So in this case, I'm going to do this as negative t over 3 minus c, but I'm just going to do plus c2 just to indicate that those two c's aren't the same. So I'm just going to leave it as plus c though. And I can solve for the c by using the initial condition. So my initial condition was t is 0, a is 0, so I'm going to plug that in. So solving for the plus c, I'm going to end up with log 12 minus 0, 0 for y, and that's going to be 0 for t. So solving for c, I end up with c is equal to log 12. Okay, so once I have that, I can just plug that back in and solve for the y. So I'm going to use this equation here. I'm going to convert this into an exponential function. 12 minus y is equal to e to the power negative t over 3, and c2 is log 12, so plus log 12. Okay, now that plus log 12, we really should show this as the coefficient or the exponent. So I'm going to do that first before I rearrange this. So this plus log 12, I'm just going to change the color here. This portion here, I'm going to rewrite that as e to the log 12, which is an identity that's going to end up being just 12. And then we end up with times e to the negative t over 3. And then simplifying this, we get 12 as my coefficient on the e function. So simplifying this, we get y equals 12 minus 12 e to the negative t over 3. Okay, so this is a solution to this differential equation.